Assalamualaikum and good day. My name is Muhammad Ali Faikal bin Abdul Rashid 1811511593 from RK85. Now I will present about the development of U-shaped optical fiber in application of glucose detection for my final year project 1. My supervisor is Dr. Nur Hamidah Abdul Halim. In this video, I will outline the introduction, problem statement, objectives, project scope, methodology, and Gantt chart. Fiber optic is a filament-shaped optical waveguide usually composed of glass. It is a cylindrical dielectric rod and the light propagates through the fiber's core. Optical fiber sensor mechanism in relation to light propagation in optical fiber follow the rules of total internal reflection TIR and also Snell's law. Total internal reflection says that if the angle of incidence is greater than critical angle, there will be no reflection of light and the rays will be totally internally reflected. Fiber optic sensor have a variety of advantage over traditional sensor. It is higher sensitivity and geometric adaptability. Geometric adaptability means it allows of creation of arbitrary shape. The goal is to present the work performed for glucose measurement utilizing the U-shaped optical fiber sensor. For my problem statement, I want to figure out the best and suitable design of U-shaped optical fiber for optical sensing. I also want to determine what will be the minimum power for detection of glucose concentration solution. The accuracy of fiber optic sensor as a function of bending angle for different length of cladding removal. Next, my objective is to design and fabricate U-shaped optical fiber at different angle on a cardboard for optical sensing. I also want to measure the power of different optical fiber angle in glucose solution using optical fiber setup. And lastly, I want to evaluate the power of various diameter optical fiber at different glucose concentration. Next, for the scope, fabrication and setup of the optical fiber using specific tools. The optical fiber will be positioned on a cardboard to produce a shape that alters the fiber's total internal reflection. The output will have different UV spectrum over power dBm depending on the design variation. For my methodology, I will using a white rope on a piece of paper to illustrate the optical fiber setup. The specific angle and stripping coating area will be marked using blue mark on the white rope. With the wavelength, based on the Taguchi method, wavelength contribute the highest contribution followed by dimension and loops. The longer the wave, the less the attenuation. For the optical fiber fabrication, I will start by fiber cutting the optical fiber. Next, I will inspect whether the optical fiber is damaged or not. If yes, I will repeat the fiber cutting process. If no, the fiber optic will be cleaned with solvent. Next, I will strap the fiber coating and put on the fusion splice protective sleeve to protect the fiber from break. Next, it will undergo the cleaving and fusion splicing method. If the splice loss is less than 0.05 dB, I can proceed with the next method. If not, I must repeat the cleaving and fusion splicing method again. Next, I have to heat shrink the protective sleeve and the optical fiber will be placed on the cardboard. Variation design of angle of U-shaped optical fiber will be designed on the cardboard and I will check the adequacy of the angle. If it's adequate enough for the testing of different concentration of glucose, I will proceed with next method, which is glucose solution preparation. Glucose solution preparation start with weighing glucose on the scale and fill up 250 ml of distilled water. Both of it will be mixed up in a container. And next, I will prepare 5 different concentrations with highest concentration to the lowest concentration based on the stock molecular stock mole. The 5 different concentration will be put into the 5 different test tube. Next, the glucose concentration testing can be done. Next, for the reflecting index testing, first I have to clean the prism using 4 to 5 drops of DI water. This next I have to wipe the prism until it is completely dry. After that, I have to calibrate the digital reflectometer using 4 to 5 drops of DI water. If the reading gets 1.3330 of reflective index of DI water, I can proceed for the next step. If no, I have to repeat again from the first step, which is to clean the prism using 4 to 5 drops of DI water. For testing the refracting index of glucose, I have to place 2 to 5 drops of the glucose solution on the prism. Next, push the read button to detect the refracting index, and the refracting index for the glucose will be recorded. For the Gantt chart, this is a Gantt chart for final year project 1 in semester 1. For the weeks 1 until 2 is title selection and briefing about optical fiber from my supervisor. From week 2 until week 7, I gather some research and information for my literature review. On week 5 until week 6, with aid of my supervisor, I have to prepare the glucose solution with 5 different concentration. On week 7, I have to submit my progress report 1. During week 8 until week 10, I perform the fabrication of optical fiber in the university. For the progress report will be due on week 11. From week 12 until week 13, I designed the U-shaped optical fiber using the white rope on a piece of paper for illustrate the optical fiber setup. Ultraviolet visible spectroscopy testing will be held on 13 to 14 week, and the determine the refractive index also using digit also will be held on week 13 and week 14. Full report submission will be on week 15 and viva presentation will be on week 16. For my semester 2 plan, I plan on week 1 until week 3 to fabrication of optical fiber based on design chosen. From week 2 until week 6, I will try to perform the glucose detection and gain preliminary result from week 2 until week 9. Collecting and analyzing data will be from week 7 until week 11. Discussion on the result will be from week 9 until week 13 and finalize the report on week 12 until week 14. Thank you.